Welcome to lecture one. Today we're going to be going through the an overview of what Java is all about. So let me open Notepad and let us talk a bit about Java. Get to know Java a bit better. But before we get started, before we go into what is Java, all those things, like all the necessary information you need to know about Java, we need to take a step back and get to know what are we doing? What is computer science? What is programming? Like what are we doing in general? So let's look at the following terms, right? Let's start with the term programming, right? So that's the whole point. We are programming. Programming, we're just basically making programs. So programming, we can say is the art of creating software, which is also called what? A program, right? It's also called a program. So that's where they get the word programming, because we are making programs, right? And now what we need to know is, what is a program? A program is basically a set of instructions that tell the computer what to do, right? So a program just is basically a set of instructions, right? And these instructions, they are comprised of what you call statements in programming language, in programming languages. They are called statements. A statement in basic terms is basically, like, you can link it to the English, to your native language, whatever your language is. So instructions, they can be likened to, or we can compare them to what? A sentence, right? So a sentence has like starting, it has a starting and an end. It has also specific rules that you have to follow. So for example, to start a sentence, you need to capitalize the first letter of the first word in the sentence, right? So you can't, there's specific rules in order to structure a sentence. So let me cancel this. So for example, you want to write a sentence like, I am going to school, right? This is the more correct version, or the more correct way of writing the sentence, right? Then there's other ways of writing it without following the rules. You can just say, I capitalize am going to school. Yeah. And you don't even put a full stop. So that's the problem with not following the rules, right? The set of rules that were created to represent a sentence, right? So the same applies in programming, because in programming we have what we call statements, which are equivalent to a a sentence in English or in any language. So what would be the equivalent of, remember, this is a sentence, right? So what is equivalent to this sentence in programming language? It's anything that's terminated by something, right? If you look at this statement, this sentence, right, it's terminated by a full stop. It means that this is the end. This is where it ends. This is the whole statement. This is the whole sentence. So how would you terminate statements, and how would you structure it? It depends on the programming language, right? That's why some languages have special characters. So for example, okay, it opened a new tab. So for example, let me see if I can generate a special character. Um, let me see, is it Shift K? But yeah, you know some languages, right? They have special characters. Like let's just just search something real quick. I hope it shows special characters. No, it doesn't. Let me say, okay, it doesn't. But yeah, as you can, let's just see this one. How much I love you, right? So let me just change this to how much I love you, right? Um, okay, I just wanted you to see the special character. You see, it depends on the language. Some languages have special characters. It depends on the rules of that language. So remember that the art of programming, right? The art of just writing programs, right? It's mimicking the real world. If you check everything that I've stated so far, I'm relating it to the world that we live in. I'm talking about statements in programming. I'm saying they're equivalent to what? Sentences. Just like in Java, this is how you'd write a statement in Java. Statement in Java. It's anything terminated with a semicolon. So for example, I can declare a variable. I can say int number, semicolon. If you look at this and you look at this, they are similar. Look at the sentence. It's terminated by a dot. This is terminated by a semicolon. There's rules that I've followed. I've used the keyword int. That's one of the rules. I've named it. I've given the variable proper name. I've also followed the rules. So it's very similar to English, to any language that you speak. There's rules involved. So as I was saying, the program is just a set of instructions, and those instructions it's just a set of statements. You can say instructions or statements or sentences it if it confuses you a bit. But yeah, these words are just interchangeable. But the correct keyword for it or the correct term for it, it's instruction. But you can use other words to give it more meaning so that you understand it a bit better. You see, statements, sentences, one and the same thing. So yeah, we understand what programming is, right? It's the art of creating software, which is also called a program. We are creating a program. That's what programming means. Like for example, if I say I am running, right? This is derived from the keyword run, right? It's the same thing. If I'm programming, what am I doing? I am writing a program. And what is a program? Because in order for me to understand programming, I need to understand what a program is. I need to have a definition for what a program is. A program is just a set of instructions or statements or sentences that tell the computer what to do. Full stop. It just tells what the computer should do. For example, if I click if I do this, if I tell you see I've clicked on my keyboard, right? I've clicked the Windows icon on my keyboard. That's an instruction. I am typing right now. I'm gonna type right now and say notepad. You see, that's an instruction. I'm instructing it on what to do. I'm giving it commands. That's what the program is. It's just a collection of commands or instructions that you wrote that tells what the computer should do. It's as simple as that. So that's what we are doing with programming. We're creating programs. We're creating something that contains statements or sentences. But those sentences, they follow a specific programming language syntax or rules for that programming language, just like the just like Spanish has its own ways of structuring sentences, which is different to maybe French or English. Each language has its own specific way of structuring its sentences. Same applies to programming languages. Some programming languages don't have semicolons. You don't terminate with a semicolon. That's Python. It depends on the language that you are learning. In our case, we are learning Java, a very powerful and very efficient language. So we have a bit of understanding of what we are doing, right? What is programming? And I can give you examples of programs, right? For example, Microsoft Word. That's a program. This is a program because it contains a set of instructions that tells what the computer should do. But then if you look at Microsoft Word, right, the way it's structured, it's more of a graphical approach, right? There's things to click. So if I double click or I click once on this, it should open the area for me to start writing, right? That's an instruction that was written by the developers or the people who made or created this program, right? So we should also become familiar with this term, developers. These are just people. These are people who made the program. So when I say the developers of Microsoft Word, I mean the people, the makers, the people who made this program, this app. Sometimes they use the term applications, if you're more familiar with that term. So program, you can call it a program or application. They're interchangeable. It's literally one and the same thing, but one is more simpler than the other, and it's more easy to understand. But we use the keyword program. That's a proper term for it. So as you can see, this program or this application, it has instructions, right? So for example, if I start pressing my keyboard right now, you can see letters on the screen. Those are one of the instructions that were written for this program. So one of the instructions was that if the user starts typing the keyboard, you should show whatever they use the specific key that the user has typed on the keyboard. That's one of the instructions. So we have apps everywhere. We have our phones, we have WhatsApp, we have Instagram, we have Twitter, we have all these applications or these programs, or yeah, programs in plural, of which were made by developers, software engineers. That's another term for it. They were made by these people, right? That's what we're doing in general. We are taking a problem and creating a program that solves that problem. For example, airtime is expensive. So why not create an app or a program like WhatsApp so that it's cheaper for people to communicate with each other? Or you or another problem that they were solving is this thing of having to send each other emails. It takes time. You don't get an instant response. You're gonna email someone, and then it's gonna take them like two or 3 days, even a week, for them to receive your message. Then they respond back to you. Then it takes a whole nother week for the response to get back to you. So someone was like, you know what? Let me develop this program called WhatsApp so that it's easier for people to communicate in longer distances and they get instant responses. So we've been surrounded with programs. For example, Your microwave, your microwave has a program inside or software inside. And that software is instruction that tells it if the user clicks on that button, you should start warming up the food. If the user clicks the defrost button, the microwave should start defrosting the food. It's everywhere. Programs are everywhere. They're in our daily life. So that's what we are going to learn now. We're going to learn how to make those programs on our own. It's not going to be an easy journey, but you just need to be a bit more patient. You'll eventually get there. Patience is really it's a key. It's very important. So we have a bit of an understanding of what programs are. So we know what programming is, right? So now we need to get to the concept of programming languages, right? Programming language, right? A programming language is basically, in simple terms, remember what we talked about. Remember what programming is. It's the art of creating software, which is called a program, right? We are creating software. So in order to create the software, we require something called a programming language. If you're very attentive, you're gonna see this thing is sort of like self-explanatory. There's a language for what? Programming. What is programming? Creating software that is also called a program. Basically creating an app like WhatsApp, whatever. That's programming. That's what you're doing. So in order to create those things, we need what we call programming languages. Languages that are used to program or to make programs, as from the term itself, programming language. So this is just the language required to make that software or program, right? That's in simple terms, that's what it is. So why do we need programming languages? Some might ask, why? What's the point? So the point is that computers are a bit complicated. It's a very complicated tool or system. A computer is very complicated in the sense that if you want to make these applications or these programs like WhatsApp, whatever, they needed to make what they call a programming language. Let's see why. So in order to understand what programming language, what's the point of a programming language and all of this, let's take a let's take a stroll back in history, right? Let's have a history lesson, right? So this is, I'm gonna create this and put it there, then put this one there. So let me demonstrate it in simple terms, right? So let me make it full screen. Yeah, there we go. So you can imagine there's three people, right? They are trying to, okay, let's just put this person aside, on the side a bit. Imagine these two people, right? This person wants to communicate with this person, right? They're trying to talk to each other, but there's an issue here. What's the issue? The issue is that this person speaks Spanish and this guy speaks Italian. That's the problem. So now I'm sure you're asking yourself this question: how are they going to be able to understand each other, right? That's where the interpreter comes in place. If you look at this, or yeah, I know English can be a problem, so I'm gonna say translator, or a fancy word for it is interpreter. So this middleman needs to know both of the languages, right? Or at least, yeah, it needs to know both, because he also needs to get language. He also needs to get information from this and then translate it to Spanish, and then get information from this Spanish guy and translate Spanish to Italian. So he needs to know both languages. This is the middleman. This is the interpreter. So this guy is going to send a message to this. This guy translates it to Italian, and then he sends it in Italian in Italian to this guy. So in a nutshell, this is what usually happens, right? We speak different languages, right? So now in terms of the computer, you can imagine this guy on my rightmost side is the computer. So the computer speaks binary. It speaks in binary. Binary, you know the word bi means two or more than one, but two. Yeah, exactly two. Bi means two. So it speaks in a binary. So let's call it okay, binary, right? It's usually called machine code, or just say machine language to simplify the thing. This is the language that the computer can speak, right? It speaks machine code or machine language. That is its language, right? Then there's you. You speak English, right? you might be wondering, like, you might be like, okay, this is understandable, right? So why, how come, what is this? How come programming languages are not written in English? Or how come you just don't speak English to the computer and then the computer understands us? You see, there's a bit of an issue with using English. And they chose English because it's the most widely used language out there. So yeah, we're gonna assume at least everyone out there, even in low income households, they at least get taught English in schools. So that's why I'm using English. I'm not using Italian or Spanish. It's not that popular. It's not like it's not like it is popular, but not that popular like as in worldwide. Like even in textbooks, every institution has the textbooks written in that language, right? It's not the case. English is the predominant one. So that's why I'm using English. Some people might be like, "Wait, why don't you use English? Why don't you communicate with the computer?" It's simple, right? Straightforward. Yeah, it's not that straightforward. Remember in English that you can have one word that is 3 or 4 different meanings. And remember the computer speaks in binary, right? It speaks remember we said binary, bi means 2, right? Means 2, right? So it speaks in binary. So what is these 2 things that it speaks in? So it speaks in ones and zeros. That's how it speaks. So for example, if you wanted to say hello in binary, right? It would be something like this. You see, that's how it communicates. It uses only 2 digits to communicate. You might ask yourself, how come it knows the letters? Yeah, we'll get to that. But in simple terms, hello would translate to something like this. That's not the direct value, but I'm just saying how this is how it would look in the language of the computer. So it would look something like this. So you see, let me see if I can make a perfect example of this. Words in English that, let me see. Let me just say one word in English many with many definitions, or with different definitions. Yeah, let's use the keyword even, right? So you can say even, like as in the number is even, right? Or you can use the word even, right? Like we are even, right? I paid you what you owed me, and you paid me. I paid you what I owe you, and you paid me what you owe me, right? We are even. You see. So how would you tell the computer to know the differences between this even and this even? It becomes a bit cumbersome, right? it becomes um it becomes very messy. It becomes a very untidy thing because now the computer speaks in only ones and zeros, right? So there's no room for like intuition or yeah, spirituality, whatever it can infer based on what you said. It can say, oh, I must assume that based on how they structured their sentence, they meant that even, not this even. You see, it doesn't work like that. A computer, in simple terms, a computer is just all logic. That's why it only speaks in binary. Binary meaning that 1 represents yes, 0 represents no. So it can only be yes or no. Unlike us people, whereby we have our own specific digit for maybe. That's where intuition comes in place, right? There's always a maybe. So someone can tell you a sentence and you can sort of like, oh, maybe this is what they meant because based on how they've structured their sentence. In computers, there's no maybe. It's either yes or no. That's why you see it only uses 2 digits, not more, not less. So using English becomes a bit problematic because one word can have multiple meanings. So you can use maybe use maybe the keyword kill, right? You can say I killed it. I killed it, right? And then you can say kill as in I will kill you, right? And then you can say, yeah, there's many. You see, that's the problem with the English language. One word can have multiple meanings, multiple definitions. So English is out of the English is out. We can't use English to write our programs, right? I can't code an app. I can't code WhatsApp using English because the computer might misinterpret. Yeah, it might misinterpret my my statements, right? My sentences. It will be like, oh, I killed it. And then it goes it goes on a rampage and starts killing people. And that's not what I meant. I just meant I killed it in a positive manner, right? So it becomes tricky. So now the question is, if it's that tricky, how are we going to be able to come up with a language that's not like sort of like two-faced in a way? Like there's different versions of one word. Which language can we use? So if you look at our diagram again, there's English, right? There's the machine code, zeros and ones, right? The language of the computer. So now we introduce what we call a programming language. Programming language, right? So with this programming language, right, it removes all those it removes all that confusion, like one word having multiple meanings or whatever. It removes all those things. So now it becomes just like this, right? This is now how it looks. There's the programming language. It gets translated or interpreted into the computer, language, and vice versa. You can convert that back to programming language. So in simple terms, that's how it is. You write in a specific programming language and then you translate it to the language that the computer can understand. So the purpose of this programming language, of that language, is that it doesn't have that confusion, right? Remember what we talked about. Words can have multiple meanings. One word can mean a lot of things, and it can be used in different ways. So to remove confusion, you programmers created a specific programming language. So now you're going to ask yourself the question. Now the question that you're going to ask yourself is, why do we have so many programming languages? That would be a very good question. It's a fair question because, like, what's the point? Why do you have Python? Why do you have C++? Why is there Fortran? Why is there Ada? Why is there Simula? Like, why are there so many languages, right? The thing is that you can look at this. Remember that programming languages are similar to language, right? To like our language that we speak. Remember that there was Shakespearean. I think I spelled it right. I don't know, but yeah, Shakespearean language, right? Like they used keywords like thou, thy, art, things like that, right? At that time, it made sense. And then people, as time goes on, we evolve. There's this thing called evolution, right? We evolve as people. Then we make the language better. Then we end up having like English, simple English. The that in simple terms, that's the best way I'm gonna explain it. So the first language, right? Back in the days, people used to code in machine code in the machine language itself. They used to write machine code. They used to write zeros and ones. Then people, as time went by, they're like, you know what, this is very, very, very difficult. Imagine, okay, for now it's just hello, it's one word. Imagine you're writing a sentence. Imagine this is what you see on your screen. Even if you know what it means today, can you wake up tomorrow and be able to tell, oh, okay, this first 4 digits mean H, stand for H. This 3 digits stands for I. You're never going to remember that. You see, it becomes very complicated. There's too many zeros and ones to keep up. So someone was like, okay, why don't we like why don't you create mnemonics for this? So why don't you create mnemonics, like short keywords for just simple instructions, right? So I can write add, I can write sub, which is just shortcut, it's just the shorthand for subtract. This is the shorthand for addition, and then mul, shorthand for multiplication, and then div, a shorthand for divide or division. Divide or division. So you see, why don't you create mnemonics, right? That's when a language called assembly language was made, right? And it kind of made things simpler because you can just write an instruction like this. Let's say you want to write an instruction that says say 3 plus 4, right? It was a bit complicated, but I'm just gonna write it in simple terms. You just write it like this. You say add 3, and then you separate with the comma the next digit that you want to add, right? So you just say add. So you just basically what this means, it means add 4 to this number, which is basically the same as this, right? So you see, it's a bit simpler now. You can read it now. It's a bit easier. You can say add 4 and 8, right? Multiply 4 times 8, right? This is the same as 4 times 8. So take 4 and multiply it by 8, which is the same as 4 times 8, right? That's when the assembly language was invented. And then developers were so ecstatic. They're like, yeah, finally we have a proper programming language. And then as time went on, they also realized there's also a flaw. There's a huge flaw in having to write an assembly, because remember, assembly is low level, meaning that it's like very close to the machine language, right? It's very close to zeros and ones, right? It's like you can imagine you're at floor number 1, right? That's like the lowest level. That's like the okay, let's just say ground level, ground floor. Yeah, there's ground floor, then there's level 1, then there's level 2, and so on, right? So ground floor, you do agree that ground floor is like the lowest level, right? So you can imagine the ground floor being the machine language. That's the ground floor. And then assembly is just the floor above. So that's why we're calling it low level, because it's close. It's like literally right next to the ground floor, right? It's level 1, it's floor number 1. It's literally next to the machine language, to the low level. So it's close to the low level, which is the ground floor. It's close to the ground floor. So it became very complicated, because now in order for you, let's put it in simpler terms. In order for you to to like um get to floor number 1, right? You have to go through the ground floor, right? That means you'd have to know how the ground floor is, where the elevators are, how everything's structured on the ground floor, right? In order for you to get to level 1, since it's close to ground floor. So that became a problem, because it being close to level 1, that means you still have to know machine language, right? You can't just write this assembly. You still have to know the hardware, right? You still have to know the computer. That's the problem that came with assembly. You have to know how the computer is structured. Where's the CPU? Where's the main memory? Where's this? Where's the hard drive? Where are the components located, and how each works and how they communicate? It became very complicated. So people are like, okay, and it differs depending on the operating system you are using, right? Kali Linux is different from Mac OS, which is also different from Windows. So they're all different. It's an operating system, but there's different, they use different approaches or different ways to making those operating system. It's totally different from each other. So imagine now you're writing a WhatsApp application. Imagine you'd have to know how the Huawei phone is structured before you before you create the WhatsApp. And you need to know how the iPhone is built, the hardware. You'd have to open it, tear it into pieces and see how each part works, how everything connects. Even Samsung, even any other phone brand out there, you'd have to know every single phone brand. The same applies with computers, right? There's Dell, there's Lenovo, there's HP, there's Acer. You'd have to know every single one of them, how they're structured, how it works, the operating system, how the operating system interacts with the hardware. You see, that's a lot of learning. So it's like before you even get to coding, before you get to programming, right? You'd have to know your computer. So you have to know how the computer is, how everything works, which becomes a very problematic thing. It makes programming very difficult. That's when they invented other languages that were more sophisticated and more. They didn't rely on you knowing how the computer is built. That's where we had languages like there's a language called Ada, there's COBOL, which was made for business people. Then there's Fortran, which was made for mathematicians. They started making different languages, right? Programming languages. Then C++ came into the picture. Then Java came into the picture. Then now we have the most simplistic language, Python, the most straightforward one, Python. But as you can see, just like with our language, how it evolved, the same applies to programming languages. There's that it's evolution. They have to evolve. They have to fix and rectify the previous problems that were there with the previous languages. So yeah, that's in a nutshell, that's how it is. So now when you write your programs in these languages, you didn't have to know how the computer is built. You didn't have to know how Windows operating system works because that's two things that you have to learn, and you have to learn for every single company that's out there making computers, making computers and operating systems. You'd have to understand all the operating systems and how they work and how it works for that specific um, specific computer model or brand. So you'd have to know how it works on a Dell. You'd have to know how it works on an HP. You'd have to know how it works on an Acer. You see, that's a lot of work. So this language is simplified that. All you have to do is just write the instructions, just write the statements. You don't have to worry about how the computer is structured, how it's built. So now we have a bit of understanding of how it works. So we have the programming language, the translator. So let's write an instruction in Java, right? So animate get text and add text here, and then zoom in. So this is how it works, right? So you write a statement, right? Remember what I said, the statement is basically the same as a sentence. It just says equals to 0 like this, right? So let's say this is the message that this person says in their specific language. And then they pass it to this interpreter, right? The translator. The person is going to translate what this means so that this guy, the computer, understands it. It gets translated to his native language. He gets to understand what it means. Then this guy translate, and then he comes up with the equivalent, it comes up with the message in that guy's language. Let's say the message was something like this. Yeah, that's what it translates to. And then this guy, this translator guy, it sends that message, this message to this guy. And then this guy receives the message. Then he's like, oh, I know what you mean. You mean I should create a variable and then initialize it to 0. Okay, I understand the message now. And then it does that. So this is a whole procedure that goes on. You write an instruction or a sentence or a statement in a specific programming language, then a specific translator translates it into machine code. It translates it into zeros and ones so that the computer can be able to understand, because the computer, you can imagine the computer is a person who's very stubborn, right? They don't want to learn any other language than their own. That's the computer. It only knows its own language. It doesn't care about learning about your own languages, and that's that's just how it is. So you have no choice but to always go through this process of translating. So now since we understand, we have a basic understanding of what programming is in general, what a programming language is, how it gets translated, what happens, how does the computer know what to do, even if we wrote it in a specific language, how does it know what to do? Because there's a translator. There's a middleman in between who's translating to your computer. So for example, when you click an application here, if you check here, I want to open code blocks, right? If I click here, an instruction was sent to the computer to open this app, but it had to be translated to the language of the computer, which is zeros and ones. But it did it so fast that it's almost in the blink of an eye. You won't even notice that this is what's happening behind the scenes. It's always this is always the thing that goes on behind the scenes when you're using a computer. Even if I click this plus button here, it's the same thing that's happening here. It has to take that instruction, translate it, and then perform the specific action based on based on the instruction. So now we have a bit of a basic understanding of what's going on, right? There's this translator, we have a specific programming language. Remember, we need the programming language because English is a bit complicated. You can use one word to explain, to talk about, you can use one word to talk about different things. You can give a warning to someone. You can say we are even, which means which is a different meaning than, oh, that's an even number. You see, this is it's different, but it's the same word. So in order for us to avoid that confusion, because the computer, it has no intuition. It doesn't know, okay, I can make my own conclusion, right? A computer is not like us, because with us, we have this ability to sort of like infer from what was said. So for example, if your parents or one of your parents, let's say your mom gives you money to go and buy food. They give you money, they say go and buy bread at the tuck shop, at the spaza shop. You're not gonna just be there standing, being shocked, like, okay, and start asking her, where's the tuck shop? You're not gonna do that. You're gonna, and you're also not gonna ask her, oh, do I need to wear shoes to go there? Or should I walk barefoot? You see, that's how a computer is. You have to write every single step explicitly, step by step. You have to tell it, okay, take this money from my hand. Then it takes the money, put on some clothes or put on some shoes. Okay. Open the door. Okay. Close the door. Okay. Go to the gate. Okay. Take the keys out of your pocket. Okay. Unlock the gate. Okay. You see, you have to be explicit step by step, every single step. That's how the computer is. So it wouldn't know what you mean. What's the difference between we are even and, oh, this is an even number. All it sees is just the word even, even. That's all it sees. It doesn't know that there's tone. With tone comes a different, there's a different meaning. Oh, we are even. Oh, this is an even number. You see, the tone has changed. It can't tell from the tone. So yeah, just keep that in mind. So there was a need for a programming language which simplifies. It removes all the ambiguity. It removes all the confusion that, oh, okay, what if this even is used in this way? How would I respond? No, there's no such things in programming languages. Programming languages, it's a language that's very straightforward. One word, each word has its own unique meaning. There's not more than one meaning for that one word. That's how that's how much programming languages are useful. That's how useful they are. So we've talked about binary. This is the language of the computer. It speaks in zeros and ones. And we said 1 means on, 0 means off. Just like a switch, right? There's on and off. 1 would mean that the switch is on. And then 0 would mean that the switch is off, right? Remember that your computer works with electricity, right? There's this thing called transistors. So with these transistors, it's like you can imagine that it's like on and off buttons. So whenever it gets the electricity, you can either have electricity or the transistor can not have electricity at all. So it can either be on or off. Remember, whenever you need to use your devices, you have to charge them. You have to feed them energy, which is electricity, which is equivalent to us eating food. Before you do something, you need food, you need to eat, or else you won't have the energy for it, right? So it's the same thing. And I'm gonna keep repeating this. Computers, what their goal was to mimic what we are doing in the real world and then do it in a more efficient way. So for example, when you use a calculator, you get the answer instantly just like that, right? Try calculating the answer in your head. It's a few people who can do that. So you see, computers, programs, all these things, they help make our lives easier. So we have an understanding of what it means. All right, so let's talk about Java. Why Java? So the nice thing about Java, one of the things that I like about Java, right, is that Java is platform independent. So it's platform independent in the sense that you don't basically it follows it is the war philosophy, right? I think it's called war philosophy, which basically means you write once and run anyway. So you can write it on your Windows operating system, and that same program that you ran on your Windows operating system, you run it on Mac OS, you run it on Kali Linux, you run it on Ubuntu operating system. You can run it on any operating system. You just write it once. Back in the days, even till now, there's companies that still, when they develop an application, right, they have to develop it for every single operating system. So they write a program for the Windows operating system, then they write the same program for Kali Linux, then they write the same program for Ubuntu, then they write the same program for Mac OS. So you see, it becomes very problematic. There's a lot of work that you have to put in place. One thing you have to write it 3 times, minimum of 3 times. So imagine WhatsApp. You'd have to write code WhatsApp for Android and code WhatsApp for iOS. So you'd have to do that if you're using a programming language that's not platform independent. But lucky enough, Java is platform independent. It doesn't matter what platform you're using or what operating system you're using, it's still gonna run. And it's run through the reason why it's able to do this, it's because it's run through what we call a JVM, right? This is a Java virtual machine, right? Uh, what is it? What is the Java virtual machine? The Java virtual machine is a fancy word for a translator. Remember this middleman who's in between. That's the JVM. That's what JVM means. JVM is just basically the translator or the interpreter. That's JVM. That's the Java virtual machine. So if you read the words and the words themselves, virtual, it's not a physical device. It's just virtual, right? That's why you can run it on any operating system because it doesn't use it doesn't explicitly run it on your operating system, unlike languages like C and C++. With C and C++, it runs it on that on that specific operating system, and then it generates a platform specific binary file. Basically, the file that contains the instruction the instructions for the computer, but translated into the language of the computer. So remember that our computer speaks in zeros and ones, right? So after translation, it creates a file um, in C++. It's called I think it's called an object file, but yeah, it creates a file whereby it contains the machine language. So it contains the language of the machine. So depending on the platform, it creates the file specific for that platform, which means that if you generate a file with the binary code in Windows operating system, it won't run on Kali Linux. It won't run on macOS. You'd have to run it inside that operating system so that it generates the file that's specific to that operating system. Usually with Windows, we have what we call a .exe file, right? Which is in short, the exe stands for executable. It's an executable file. So that's what happens after translation. It creates a .exe file. When you are dealing with what is this languages like C or C++, they are not platform independent. They run on that specific operating system and they generate a file based on the specific operating system. So if you run it on if you run it on what is this currently on Linux, any Linux distro or any Linux operating system, right? It's gonna create a .a file, right? Yeah, .a file. So you see, you can take a .exe file and try to run it on Linux because they're incompatible. Linux runs files that have a .a extension, and Windows runs files that have a .exe extension. So yeah, that's why we're saying Java is platform independent. It doesn't create all these things. It just creates I think it's a .o file for, I think it's a .o, right? We'll see. We'll just double check. But yeah, it creates a file a file containing the binary code, and then the file gets run via the virtual machine. You don't run it on your physical machine. You run it on this invisible. Remember, virtual is like an invisible, something that we can it's not physical, it's not in the sense, of like a cup or a plate that you can physically touch. It's it does exist, but it's somewhere there. It's like on the cloud. That's the term they like to that I can use for you to understand, but it's like on the cloud. It's not physical. You don't have it next to you like a chair. You're sitting on a chair. It's a physical object. This one is a non-physical object. So that's why it can run anywhere because you just need to have a JVM on that operating system. Then you take that same file that you executed on Windows and you run it via this JVM. Then the JVM is going to translate it to it's gonna no it's not gonna yeah, it's gonna translate and execute the instructions based on that file, right? Those zeros and ones, it's going to do what it's supposed to do. So that's one of the benefits. It's platform independent. It doesn't matter if you write it on Windows, it can still run on Kali Linux, it can still run on Mac OS, it can run everywhere. That's the nice thing about Java. And then Java is also Java also has what we call Java is, let's just say Java is secure. That's one of the benefits of Java. Java is very secure. So for example, for those who have experience in C++, they know what I'm talking about. So in C++, you had pointers, right? In Java, there's no pointers. So it becomes very safe because you don't have to worry about using memory of which that was already allocated. That was already deallocated. You don't have to worry about trying to deallocate it again or trying to access memory that has not been allocated. So it's very secure. And it also removed multiple inheritance. So there's no multiple inheritance because there's problems that you encounter, especially if you did C++. You'd encounter, I'm sure you've encountered problems with multiple inheritance, like diamond problem, this and that. There's many problems that you can encounter with multiple inheritance. So it's also very beneficial in that case because it doesn't have pointers, doesn't have this. And yeah, secure, and it is, yeah, being secure. I'm just putting all the things that Java has. I'm not putting them in a specific order, it doesn't matter, but I'm just explaining the whole philosophy behind Java. Java, you can yeah, Java is platform independent. Java is secure, it's safe. Java is also robust, right? Java is a robust language. It checks, you can, it's very robust, like it checks, there's checks everywhere. Before you even run your program, it checks for potential errors, all those things. Yeah, Java is it's very robust. That's one of the benefits of it. Then what's another thing? Yeah, Java is object oriented. Remember that most languages, the way they were created from, they started from, they created from the procedural perspective, right? So they started creating the language like as a procedural language, right? Like only working with functions, right? That's where they started. Then as time goes on, they're like, oh, okay, this is a new trend. There's a new thing called object-oriented programming. Let's add that concept inside, right? So if you check the structure of C++, right? You have hash include IOStream, right? And then you have int main, right? This is the structure of a simple, this is the structure of a main.cpp file that you need in order for, that's going to serve as an entry point in order for your program to run, right? So it's going to need a main function. This is a function. But then with Java, it was from the get-go, they thought about Java from an object-oriented perspective. So object-oriented perspective, meaning that they view it in terms of the real world. So they interpret everything in the real world as an object. For example, a cup is an object, and an object has specific characteristics and traits, whatever. Then we have also a chair, we have a bottle, etc. So that's the perspective that the builders or the creators or the developers of Java had in mind. They had object-oriented in their mind, which with object-oriented programming, it makes it very flexible. It's flexible, it allows reusability, you can reuse code. Um, it makes It makes coding easier. So that's another character trait of Java. And Java is also multi-threaded. So with multi-threading, right, it's a concept that you will go through a bit later. Yeah, it's a bit later because we need to get an understanding of what Java is first before we can talk about the more advanced concepts. Like we need to know how to make how do you make a statement in Java? What's a simple program in Java? All those things we need to baby step. We need to start um, at the bottom and then we eventually get there. So Java is multi-threaded, meaning that it can um, execute multiple tasks within one program, right? You can perform multiple things within one program. What do I mean? So for example, you can, let's say Microsoft Word, right? You can open Microsoft Word, right? You can, you see there's multi-threading here because I can type here and I can also view the layout. I can also click this. I can do multiple things at once in one program, right? Or for example, let's make a simple example. You can, for example, say you can, for example, just go download a movie, right? And then you let's say you open this movie, right? You want to download a movie. And then you click to download the movie, right? While that movie is downloading, you're opening a new tab. You're doing something else. You're watching YouTube. There's multitasking in one. That's basically multi-threaded program. It's completing multiple tasks within one program. So for example, just like WhatsApp, if you look at WhatsApp, it is multi-threading because you can make a phone call. While you're on the phone call, you can be posting your status. You see, that's two tasks. The computer interprets that as two different tasks. You are uploading a status, or you're uploading a status, and you are calling, you're making a phone call. Those are two different tasks. So that's called multi-threading. So we're gonna get to that. But multi-threading, it usually involves like networking. It's it's done in it's used in graphical user interfaces, right? And computer networking. Like I said, you can be downloading a movie. This is a graphical user interface. Chrome is it's a graphical user interface program, right? It is a graphical user interface. So you are clicking things here and there, buttons, this and that. That's what makes it graphical user interface. So yeah, we have that graphical user interfaces, computer networking. That's where it's usually applied. So that's Java. There's no multiple inheritance in Java. There's also no Java has no preprocessor. There's no preprocessors in Java. It doesn't have like hash include, blah, blah. Nah. It's Java's way of doing this is equivalent to saying import. It just imports it, but it's not like hash include. It's not the same. So there's no preprocessor, what. And what else can I say about Java? Yeah, yeah, just a few other basic knowledge. Java was made by Sun Micro Systems, right? But it is now owned by Oracle, right? And the person who was in charge of the development team while they were developing Java, his name was James Gosling, right? That's the guy who was in charge. So that's a bit of knowledge about it. And Java, if you look at the name Java itself, Java, what does Java mean? What does that name mean? Java is basically a slang for coffee, right? So if you check the logo for Java, it is a coffee. There's a coffee cup, right? Let me say Java. Yeah, look at the Java. There's a cup of coffee there. So yeah, it's a slang for for coffee. So that's why they named it Java. That's what Java means, so that you know what's going on. So Java is slang for coffee. That's pretty much you have to know. Yeah, that's pretty much you have to know. Since now okay, an hour has passed. Yeah. So since now we are kind of a bit familiar with Java, right? Let's see how you would create a simple application in Java. Let's just say hello world, right? What are the steps? We want to create a simple hello world program, right? So I'm not gonna open an IDE, right? Remember that an IDE is an integrated development environment, right? So basically it's like a place where you can do that specific task. Just like just like you can't play soccer in your room. There's a soccer field out there, there's a stadium. They can take for example, what is this? Real Madrid versus Inter Milan. They go and play in a room. That's a match, and people have to watch through windows. There's environments, there's places for people to do specific tasks. The same, which is the same for programming, right? There's a tool that you need. There's an environment or a place where you can code, where you can write programs, where you can create programs, where you can write instructions. Because the specific rules in each programming language, like as we've discussed. And these tools, the IDEs, integrated development environments, they format into according to that language. So you don't have to worry about formatting. So they're very useful. And they come with extra tools. They also come with interpreters that translate your code to machine language or to machine code. So yeah, it's a very useful environment or tool. So we're not going to use that for now. We just need to get the procedure of what really goes on behind the scenes. So let's see what goes on. So how would you create a Java application, right? So this is how you create a Java application. So let me open Notepad++. So there's Notepad++, right? So Notepad++, I'm gonna change the language, right? To see, this is just a text editor, right? It's not an IDE. So it doesn't have all the other special tools whereby it can format and put the lines, the specific number of lines required, etc. You see, there's also other languages. There's Ada. This is just for highlighting. I just want to choose Java here so that it highlights. It knows that I'm writing Java. So the way you create a Java application, right? The first important thing that you need to know. It's object oriented. Everything that you write, you have to write it in terms of objects. So you have to create a class. If you remember C++, right? We have hash include IOStream like this, right? And then you have int main. You have int main like this, right? And then you have return 0, right? And then you have standard namespace cout hello world, right? And then standard namespace inline, right? So this is the most common structure that languages follow, right? So they have function. This is a function. And each programming languages needs a main function or an entry point. Because what happens is that when the interpreter comes to interpret, right, it looks for what we call a main function or an entry point. That's the entry point. That's where it enters first. So everything needs to be placed within the main function. But with Java, it does it in a slightly different way. You don't create, remember, it's object oriented by default. So the first rule with that the file that you're, excuse me, the file that you're using or the file that you're creating, right, to write the statements in Java, first things first, you have to name it the exact same way as what is this? As the name of the class. So if you're gonna name your class main, you're gonna save your file as Java, as main dot Java, right? The .java extension, it means, oh, this is a Java. This is a text file that is written in the language in the Java language. So that's how we know. So I'm gonna press Control S to save, and then I'm gonna call it main, right? Let me save it. Let's see. Let me create a folder inside my downloads directory. Let me create a folder. Let me call it Java. Yeah, I'm gonna save it inside here. And then I'm gonna call it main.java. I'm gonna add the .java extension. And then I'm gonna click save, right? So I've clicked save, there it is. So how do we go about creating a hello world program in Java? Remember that in other languages, just say int main, right? Well, with Java, it's object oriented. Everything that you do, you have to place it inside a class. Everything that you do, you have to place inside of a class. Before we discuss classes, we'll get to classes. Let me not rush it. Let me not try to do everything in one video. I'm gonna like break down what a class is, what is object-oriented programming, then we can continue from there. So the first thing that I need to use is the public keyword. So public, and then class, the name of this class, right, is the same name as the name of the file without the .java extension. So what did I call it? Main. So my class, I'm gonna call it main, like this, right? And then now I can have that main function because now it's gonna be within this class. Right? So I'm gonna call it, this is always how you structure it. You're gonna say public static void main, right? And then you're gonna have string, an array of strings, arguments, and then there we go. And then now this is my main function, right? Remember that oh, I forgot to talk about something very important. I just missed it, but yeah, it's very important. Something that's very important, Java, right? Java has two important things. It has automatic memory allocation and an automatic garbage collection, right? So there's automatic memory allocation and automatic garbage collection or automatic memory collection. What do I mean by this? So you can imagine memory allocation as you making room or making space for you to put something, right? So you can imagine you have a washing basket, right? And there's there's things inside, right? You have let's say you're washing your clothes, right? And there's clothes inside the washing machine that you want to take out and put them into the washing basket to go and put them on the washing line, right? That's what you want. That's what you want to do, right? You can't take that washing basket it has other dirty clothes in there. You have to empty it out, right? To create space, enough space for you to put those clothes, right? So that's the same thing that we're doing here. We're creating space so that we can be able to put those clothes inside. And then there's this concept called garbage collection. When we are no longer using it, okay, I should have used the plate example. With clothes, it's a bit weird, but yeah, let me use a plate. So let's say automatic memory allocation, right, is you cleaning the plate, we're allocating memory, are preparing to allocate, or you can just say it's you cleaning it. No, it's not cleaning. And what am I doing? I'm mixing up the things. Automatic memory allocation is you allocating enough memory to put that thing, and you end up putting the thing enough to fit that size, right? So for example, you want to put what do you want to pour you want to transfer 1 liters of 1 liters of cold drink into a cup, and you want to pour all of it at once, right? Obviously, you'd have to find a cup that's at minimum 1 liter. Or what's going to happen? It's going to spill over, right? So you allocate. You look for something that's big enough for you to pour that 1 liter, those 1 liter, that 1 liter of Coke into the cup. You're gonna look for a cup that's bigger. That's like minimum 1 liters. That's allocation, right? You've created something bigger enough to pour that thing that you want to pour, or to put that thing that you want to put. So after allocation, then you use it, right? Then you pour your cold drink and then you drink or whatever. So what garbage collection does, right? It's when it's no longer in use. Remember the cup you're using it, you're pouring cold drink. Let's say you also end up pouring ice cream and this and that. You ate ice cream. Now it's no longer in use, right? You're done using the cup. So after using the cup, you'd have to do what we call garbage collection. You have to clean it. You can also literally look at it as like garbage collection, like when those trucks, the pick it up, when those trucks come to not pick it up truck, when those trucks come to collect garbage, right? What happens? They empty out the garbage, they empty out the dustbins, and then you clean the dustbins, right? So that's garbage collection. You are removing any garbage that's left there, which is basically the same as you washing the cup because it's dirty. There's garbage there. It's dirty. You have to clean it. So what the nice thing about Java, unlike with C++, it's done automatically. You don't have to manually do it. And as a result, is Java is only heap allocated. So it only works with you only allocate memory on the heap. We'll talk about stacks and heaps later. For now, just know that it only uses a heap. For now, the simple terms that I'm going to use is that a stack is, yeah, it uses a heap. A stack is basically, I would say it's basically, say a stack in, yeah, a stack in a way you'd have to, let me see. Yeah, a stack in a, okay, it becomes very cumbersome now. I can't really explain it the way I want to explain it. We'll talk about this a bit later when we get to object-oriented programming. When in the next video, when we talk about what is object-oriented programming, we'll get to that. But just know Java is only allocated on the heap. Since there's no manual memory management, there's no need for me to use the stack and the heap at the same time. Everything is managed manually. And the when I decide to allocate my memory on my own, I will use the heap. So this is Java, right? We're still here. So how would you output hello world, right? So remember what is talked about, set classes, right? So how would you do that? You'd say system dot out. So system is basically a class. There's a class called system. You see, it starts in an uppercase letter S. That's how I know it's a class. So it's going to be a class, and then I call some function. I think some function or some object, yeah, but I think it's a function. And then call, no, it's not a function, it's an object, yeah, it's an object. We'll get to the function, yeah. So I call an object called out, right? And then I say dot print line, right? Print line is now the function. This is the object, right? And I'm calling it like this because of the static keyword. We'll get to that. But yeah, this is how you would write a simple hello world program, right? So within this brackets, you're gonna put double quotes, and then you just type the message that you want displayed on the screen. So I'm gonna say hello world. Okay, let's just say hello world. This is my best Java program, right? Hello world, this is my first Java program. So this is how it looks in full. So every time you want to have a main function, you must place within a class, because Java is by default object oriented. It works in objects. It's like objects are communicating with each other. Just like in a way, it makes sense in a way. If you think about it logically, right? Imagine, remember that what I said, Java mimics the real world, right? It literally mimics the real world. A person is also an object. A cup is also an object. So the way Java perceives things, right? The way it perceives code or statements, or the philosophy that it follows is that we live in a world whereby objects are always interacting with each other, right? For example, you are a person, you are an object. You are interacting with another object, which is a cup. You use the cup to pour some liquid inside. Maybe a cold drink, it may be water, and still, yeah, you're still using that object, right? And you're also an object. So these two objects are interacting with each other. The cup is interacting with the cup object is interacting with the person object. The person object is interacting with the cup object. So objects are interacting with each other. That's the philosophy that Java follows. That's why everything that you do, by minimum, at minimum, there must be a class. It's an object. That's how it. That's how the designers of the language decided to approach it. So let's try to run the program, right? How do we run it? So I'm going to open the terminal or command prompt. And then I'm going to need to find the location, right? So wait, I need to say that, okay, so I'm going to say change directory, right? You don't have to worry about this for now. So a command prompt is basically me doing the same thing that we usually do when interacting with applications, right? Remember, applications, it's a graphical user interface. There's buttons, you see. I can click here, I can click there again, I can click here, I can do all of that, I can do all those things, right? This is a graphical user interface. This is an application with a graphical user interface. So with the command prompt, it's text based. If I want to move into a folder, I type down an instruction for it to move to the folder. You see, I want to move to the downloads folder. So I'm going to say change direct. CD stands for change direct. Direct is basically folder. I mean, all I'm saying is that change the folder. What folder do I want to change to? I want to change to the downloads folder. You see, it is updated. It is moved to the downloads folder. And then I can also just say clear. Oh, it's this is an instruction for Linux, not Windows operating system. So I'll say CLS to clear the screen. So this is where I am right now. I'm in the downloads folder. I can confirm if you look at my downloads folder, right? Let's look at my downloads folder. You see, there's the downloads folder. These are the files that I have. There's a resume, there's an installer, there's the order season 2, there's Java folder, there's NPP installer, then there's Java image. We have all of those tools, right? So I'm gonna say directory, dir, so that it prints all the things that I have in that folder. You see, 20.zip. There it is. 20. Just that here you cannot see the file extensions. Let me say show file name extensions. Yeah, you see 20.zip, which is exactly the same thing that I'm seeing here. So I now know that I'm in the downloads folder. But if you look at this, right, and I need to move into the Java folder because that's where the file is stored, the main.java file that I want to run. So I also need to say cd again to change directory. So cd to Java folder and then CLS, and then I'm gonna say CLS clears the screen, remember? And then now I'm gonna say dir so that I see a list of the things that are there, the files. There it is, main.java. So how do you go about executing this this small application, the Hello World application? Remember that the machine code or the machine language, it doesn't know what system it means. It doesn't know what out means. It doesn't know what print line means. It doesn't know what are all these things. It doesn't know. I have to pass it via a translator. So now I'm gonna call my translator. It's called Java C. Java C meaning Java compiler, right? We're just gonna convert or compile or translate the statements that are inside here. Basically, what are the statements? All of these words are going to be translated to machine code or zeros and ones. So I call my Java compiler, Java C. What do I want to compile? I want to compile main.java. And then now it's running, it is compiled. If we check in our folder, there should be an extra. Yeah, it's .class. There should be this file. This is now the binary file. This one over here. This is the file with zeros and ones, but it's not necessarily going to be zeros and ones as you're about to see right now, but it is zeros and ones. Just know, you see, it's a bunch of gibberish. So imagine you trying to write this from scratch. You see this language that's here. Now the computer, this is the language that the computer can understand. It knows what's going on here because now it's being translated. This is the language of the computer. You see, it's very weird. The special characters also. How would you know? And the special spacing here and there, you wouldn't know how to structure this thing. So that's why we call someone to translate for us, the translator or the compiler. Then now, once we've translated, I'm gonna run the Java application. There we go. Hello world. This is my first Java program. So this is the procedure you're always gonna follow. You're gonna compile it or basically translate it to machine code on the machine to the machine language, then use the keyword Java to run the program. So when I say main, right, it's this main.class, but it's being executed. I don't have to specify the .class extension. I just write the first part of the name of the file without the extension. That's why it's working like this. Hello world. This is my first Java program. So yeah, this is our first Java program, and it's a simple and exciting program. So yeah, this is Java. This is the procedure that we have to go through every time you want to run this application. Even if you add a few changes here, right? Even if you add a few changes, you say system.out. Let's add another statement, right? I'm just gonna say I love Java. This is a new statement, right? Or a new sentence, right? How do I know it's a sentence, a statement? It's terminated by a semicolon. We talked about this. So what happens is that I have to go through that whole process. I have to go through the whole process because it's something new. It has to be retranslated again because remember the previous translation, it only contains this. That's what it does. But with the JVM, with the Java Virtual Machine, the translator, the latest one is a bit advanced, it's a bit powerful. What it does, it just translates only it keeps the previous changes, and then it adds the new, it only translates this new thing. Yeah, it's something like that. It sort of like tries to speed up the process of translation. It's just gonna check. Usually, okay, I think it usually does this. It looks at the previous the new file that the new code that you've written or the new statement that you have. If there were changes, then it recompiles. If there were no changes, it just uses the old file. So let's run it again. You see, I have to do that whole process again. So let me change directly. Let me change my directory to downloads folder. And then I also open the Java folder. Okay, there we go. It's still there. And then I use my Java C compiler to translate my code. The code in which file? Main.java file. And then it translates. And then now I run the main.class file. But I don't have to specify the .class extension. I just write the name that's in front, which is just main. So I'm just going to say Java main. There we go. It says, hello world, this is my first Java program. I love Java, the new changes that I've added. So yeah, so far that's all you have to know about Java in this video. This is just a brief introduction. Java is object-oriented. Everything that you do must be placed inside a class. And the way you name your class is going to be the same name as the way you name your file. Look at the first part of the file, main.java, and look at the class main. Exactly, even the capital letters, where even the capital letter M, same thing. The main function is always going to be like this. Don't try to write your main function and say MA and capitalize I. It won't work. It's not going to run. And you're going to get a funny error. So just don't do that. It's always small caps, small letters here. So yeah, that's it for today's video. Thanks for watching. I'm going to see you in the next video.